Thank you.
Thank you everybody for the nice presentation. So next we'll go into the green building session. So good morning, good afternoon, dear colleagues and friends in China and in Belgium. Welcome to the green building session of the third China-Belgium Science and Technology Exchange Symposium. My name is Lin Van Wendner. I will be hosting this session. So the green building session is jointly organized by ACPB, CBTC, and the Green Design Organization in Beijing. This session focuses on the concept and application of green building and green design, China-Belgium cooperation in building recycling, and the application of green building materials in practice. We have the invited speakers from the top universities in China and Belgium, as well as representatives of the two countries. So you can see on the screen the 7 speakers. Now it's my pleasure to introduce you the first speaker, Mr. Zhu Zongliang. So Mr. Zhu is the Director of Green Building and Energy Conservation Institute of China Railway, as well as the Director of the Green Building Professional Committee of the World Green Design Organization. So he will present the concepts of green building and green design and the current developments in China. So the talk will be in Chinese, but the slides will be in Chinese and English. So please welcome Mr. Zhu. 朱总，您可以演讲了。
我先共享一下屏幕。好，各位来宾，大家下午好。今天我给大家分享的内容是绿色建筑和绿色设计，有这么4部分内容。第一个，建筑与空间。中国城市40年的发展，应该说我们取得了这个非常大的成就，城市的面貌也发生了天翻地覆的变化，取得了应该说其他国家200年甚至更长时间的成就。这是一个照片，就是在土地招牌挂的现场的这么一个照片。应该说这张照片呢，是中国40年城市发展的这么一个缩影，也是我们每一位城市建设者的这么一个写照。开发商呢闭着眼睛拿地举牌拿地，那么我们普通老百姓呢，如果闭着眼睛买房，应该说都在这期间呢都是获益很多。当然，在我们取得很大成就的同时，我们大量的建筑其实在设计或者建设的过程中忽视了建筑的使用功能，过分的强调建筑的外观，甚至过分的强调我们要做标志性建筑，建造了大量的奇奇怪怪的建筑。我们有的时候甚至忘记了我们做建筑的目的到底是什么。当然，随着这个经济的发展，大众的审美也是越来越高，业主的这个要求呢，业主也是越来越理性。中国本土的建筑师经验也愈加丰富，设计的水平也是越来越高，甚至在国际上也是有一定的地位。当然，这很多的一些著名的建筑，其实从建筑的外表更加注重开始往这个建筑的这个使用空间的营造，更加注重使用空间。什么是空间？2500年前，中国的古代思想家、哲学家老子在《道德经》里说过这么一句话：“三直以为器，当其无有器之用；濯户牖以为室，当其无有室之用。故有之以为利，无之以为用。”这句话的道理是，也就是说和我们造房子、造容器一个道理，就是我们造一个容器，就是把里面掏空了。我们要的是里面的空间，同样建房子也是这样。我们建造建筑的目的，不是为了要一个建筑的外壳，而是为了获取建筑的内部空间。所以造房子形体只是手段，空间才是我们真正的目的。从 未来来看，那么我们以后的建筑发展，建筑的重心将会由外向内或者说是内外并重，建筑也会更加理性，更加注重对空间的营造。当然建筑也会更加绿色，更加注重这个健康和舒适。第二部分讲绿色和生态。先讲一下中国的能源状况。中国的能源首先是能源是短缺严重，能源的结构呢也是富煤，煤相对来说比较多，这个气少，缺油非常严重，每年我们都会有大量的美元去进口石油，化石能源占比比较高，另外呢能源利用率比相对比较低，环境污染也是比较严重。在去年国家领导人在联合国大会上提出了这个3060的目标，今年这个应该前几天国家也是下发了关于这个碳达峰的一个行动方案。那么在这里面呢，实际上提出了关于这个具体的各行各业的关于碳达峰的一些目标。首先，第一个就是煤炭消费要被替代，要转型升级，大力发展新能源。那这里面的新能源可能更多的是指的我们的风电和光伏发电。第三个要因地制宜发展水电。那当然水电发展是受环境的制约。积极安全有序发展核电，因为核电的安全的问题，实际上还是没有解决。世界上很多国家在发展核电上也是非常慎重。碳达峰，碳中和的这个概念就不讲了，大家都比较熟悉。去年中国的碳排放总量已经达到了100亿吨，但世界的将近1/3，那么人均也达到了二氧化碳的排放也达到了7吨。30年碳达峰以后，那么中国的人均碳排放将达到10吨。当然，实现碳中和、碳达峰，既是社会经济发展到一定阶段的一个必然结果，当然也是国家之间利益博弈的结果，当然也是我们环境保护的需要。那么从另外一点来讲，也是国家能源安全，甚至是国家安全的这么一个需要。当前尤其是进入2021年，全球的能源资源这个价格飞涨，能源形势也是日趋紧张。世界各国也都在寻求新的能源的替代战略，以求的可持续发展。当然，全球范围的能源短缺既是能源革命过程中的问题，当然可能今年情况这么严重，我觉得更多的可能是国际资本在围猎大宗商品的这么一个结果。借鉴发达国家的经验，2030年中国如果碳达峰以后，经济和社会都会发生变化。首先，经济发展的这个增速会下降，其次呢，城市化率也会进入尾声，当然这个可再生能源的利用率会这个占比会提高，人均收入也会提高。当然，更重要的和我们每个人有关系的，就是绝大多数的城市的房价将上涨发力。新能源革命，在我看来，未来影响人类进步的2大关键技术，人工智能这个是肯定的。当然，我觉得另外一点就是新能源技术的革命，可能这个都会影响未来这个人类社会的进步发展。今后30年对中国来讲，新能源的周期将取代过去30年房地产的周期，我觉得这个是成定局。那么现在我们开始的清洁能源部分其实只是开始。随着新能源技术的革命，当然这个是革命不仅仅是这个一般的，就是咱们现在说的这个光伏风电。那么新能源技术的革命一定会像蒸汽机、电、互联网的发明一样，将彻底改变人们的生产生活方式、世界格局。从城市的建设来讲，回到中国城市建设，那么40年中国城市的发展，刚才也大家都看到了，那么总结起来有这么4个特点。第一个就是我们建得非常多，全世界大概有1半的建筑量都在中国。另外一个建得非常快，我们用了30-40年的时间。当然很多建筑尤其是早期的建筑，它的寿命比较短，当然能耗也比较高。 所以发展绿色建筑是中国建筑业走向健康发展的这么一个必由之路。当然绿色建筑的技术非常多，这里面呢仅仅是列了一些相对比较实用的或者是比较适用的这么一些技术。那我们做绿色建筑设计的时候，一定要选择适宜的绿色建筑技术，不能把什么技术都用上。不管有多少技术，简单的归纳其实无非有这么4部分。第一部分就是我们首先要减少能源资源的消耗。第二部分呢，就是如果我们不得不用，我们就要提高能源资源的利用率，提高它的这个使用效率。第3个，我们要采用清洁能源，刚才也提到了。但第4个是我们做建筑的最终目的不是为了节能，做建筑的最终目的是为了给人提供一个健康舒适的环境。第3，舒适和健康。刚才也提到了，我们从建筑这40年的发展，我们建筑未来将会越来越注重对建筑室内空间的营造，也会更加理性。那么我们提供的室内环境将会越来越舒适和健康。从建筑的发展，这个图上我们可以看出来，早期的我们的建筑其实最早就是仅仅是遮风避雨，那后来有了暖气再后来有了空调，那么再后来空气还有净化，那么未来的房子一定是类似于被动房，或者是我们所说的无痕建筑。当然舒适和健康技术也是非常多，那么未来建筑的发展在舒适和健康技术的应用将会更加广泛。这里面有一个案例，就是我们早年做的一个北京湾这么一个项目，那么它实际上实现了我们这个用了节能的达到能耗非常低，碳排放也非常低，但是提供了非常舒适和健康的室内环境，温度在全年达到20到26度，湿度在北京也是控制的非常好，当然还有空气新风包括这个隔音。第4部分绿色设计。中国的这个绿色建筑评价标准经过多次的修编也在不断的完善。那它里面的评价体系呢，也是由安全、耐久、舒适、健康生活便利、资源节约、环境宜居5类。在具体的实施内容里面呢，可以简单的分为这么4部分。第一个就是接地与室外环境。当然这个土地在国家来讲是最重要的资源，也是最稀缺的资源。接地是我们做绿色建筑必不可少的一项。第2部分节材和材料利用。那么我们通过精心的设计，使用耐久好的这个建筑材料，推广可循环利用的这个新型建材体系，减少材料的这个浪费，保护环境。节水，当然这个之前我们做的也是比较多的，像海绵城市在这方面呢有很多的应用。当然节水水资源可能在全球来讲都是这个短缺的。能源节能和能源利用。刚才也提到了，我们做节能，那首先要减少能源的利用，第2个就是我们不得不用的时候使用清洁能源再一个就是要提高能源的利用率。这里面呢，因为时间原因就不展开讲，简单讲一下关于太阳能的光电系统。国家最近也是在密集的出台政策包括建设部，包括国务院。那么未来我们早期的绿色建筑的设计，可能更多的是建筑在具体的节能技术措施这方面。那么以后我们可能更多的在绿色建筑上会采用这种清洁能源，比如说光伏或者是风力发电会用在建筑上，因为之前光伏发电用在建筑的成本还是非常高。那么现在我们的技术发展到今天，其实用在建筑上，它的从经济上已经非常可行。当然未来这个建筑储能也会被广泛的用在一些公共建筑，比如说像医院、学校这方面。概括今天讲的这些内容，那么我想就是建筑我们做的目的为了获取我们的室内空间。当然我们在做建筑的同时，我们要注重绿色和环保，但最终的目的是为了给人提供一个健康舒适的环境。好，今天就给大家分享到这里，谢谢大家。
好，很感谢朱总今天的演讲。 So thank you very much, Mr. Zhu, for the nice demonstration. That we have already some achievements, but still have a long way to go on the path of green building. So due to the time limit, we'll save the questions at the end of the session, if there's some time left. So next, it's our honor to have Professor Luc Tarwe from Ghent University. He is a member of the Royal Flemish Academy of Belgium, director of the China platform at Ghent, and the National RPGE Chair Professor at Tongji University. Professor Tarwe is a long-term friend of the symposium. He presented also in the first two offline and online events. His talk today is regarding green building concepts and applications. So Professor Tarwe, I give you the stage.
Yes, hello everybody, good morning. And just switching my slides. I hope you can see the slides. Yes, and you can understand me. So thank you for the kind introduction. The subject of my talk is green building concepts and applications. And I will first start by giving an introduction to green buildings. Then I will show how this fits in the sustainability framework. And then I will show some applications regarding concrete. So green buildings not just refer to the building structure as such, but also to the processes, the construction processes that need to be environmental friendly and resource efficient, not just at the very beginning, but throughout a building's life cycle. So starting from design to construction, over operation, maintenance, renovation, and also finally demolition and reuse. Green building design involves finding the balance between construction activities and the sustainable environment. The common objective of green buildings is to reduce the overall impact of the built environment on human health and the natural environment by efficiently using energy, water, and other resources, protecting occupant health and improving employee productivity, and reducing waste, pollution, and environmental degradation. Well, I will focus in my short presentation on the efficient use of other resources and on reducing waste, pollution, and environmental degradation. Well, we must see green buildings in the sustainability framework. And as you know, this is characterized by the so-called triple P concept, where the first P stands for planet or the ecological environmental aspects, the second P for economic aspects, and the third one for social aspects, because every measure we take has some economic consequences and has some social consequences. So that's what I mentioned in the previous slide, find a balance between these three aspects. And this is not so very easy in many cases. I also want to refer to the Sustainability Development Goals defined by the United Nations in 2015. And three of them can be related to construction and infrastructure. And the number 9 is about industry, innovation, and infrastructure. And there it is stated that build resilient infrastructure, promote inclusive and sustainable industrialization, and foster innovation. Now, regarding sustainable industrialization in the construction sector, we have since almost 5 years, we have established a Belgium-China joint laboratory for industrialized construction. This is a joint effort between Ghent University, Tongji University in Shanghai, and Shanghai Construction Group. At Tongji, this is mainly linked to the so-called State Key Lab of Disaster Reduction and Civil Engineering, where they have huge facilities regarding large-scale structural testing. The Shanghai Construction Group is the biggest construction company in Shanghai, and was involved in the construction of most high-rise buildings, bridges, tunnels, and so on. And then our Manuel van der Putten lab at Ghent University, where we also have huge, large-scale structural testing facilities, but also material testing equipment and so on. Then the number 11 goal is sustainable cities and communities. The stated makes cities and human settlements inclusive, safe, resilient, and sustainable. Resilient is nowadays a very important topic in structural engineering, and well, here you see a graph which is in fact a conceptual engineering approach to resilience. And here is shown on the vertical axis a certain quality characteristic of a system, a structure. This can be quite broad. We have defined the pre-shock quality, and then at a certain moment a shock, so-called shock, appears. What's a shock? Well, this can be a structural accident, so explosions, impact, natural hazards like earthquakes and so on. But you can use these concepts also in a wider sense. For instance, in a social environment, we can have a pandemic that occurs suddenly. And then we have to look to the recovery, let's say that's the resilience. How do we get again on the quality is post-shock quality can be the same as the pre-shock quality or higher or lower. So then we have to look to the recovery time, which is linked to the rapidity of recovery. And there are some measures we can take, some structural measures that increase redundancy, more investments, of course, in the system. And in this way, we can reduce here this vulnerability. And this vulnerability defines the drop in quality we have. And the complement of it is robustness. So we have, or we should take measures to increase robustness of structures. So also again here, there are different aspects involved, not just regarding cost, not just economical cost, but also ecological, environmental, societal cost. And the third goal, that's number 12, that's responsible consumption and production. And the explanation is to ensure sustainable consumption and production patterns. Important in this whole area is also digitalization. And digitalization has found applications everywhere, let's say. We speak about smart cities, for instance. These are places where traditional networks and services are made more efficient with the use of digital and telecommunication technologies to support a city's resilience and sustainability. And this can be, as you see here, at all levels of the built environment. And connectivity, yes, there is the Internet of Things. Everything is connected and we can apply to infrastructure, and we obtain then so-called intelligent infrastructure. I cannot go into the details, but you see many connections between, for instance, traffic, buildings, satellites, and so on and so on. And that's reality. That's the world we are living in nowadays. Let me just apply some of these concepts to concrete. Concrete as a material used in structures and so on. A huge amount of concrete is produced every year in the world, 10 billion tons of concrete, and 1 cubic meter of concrete usually contains between 345 kilograms cement. This corresponds to an energy consumption of about 4 gigajoule per ton cement, and what is worse, 1 ton CO2 is produced per ton cement. So this means that 57% of cement-related CO2 emissions are process-bound. I will show you the decarbonation and calcining. And the construction sector is responsible for 5 to 7% of the global greenhouse gas emissions. So this is a huge challenge for construction industry. Not only cement, but the aggregates we use to make concrete. There are 3 billion tons of aggregates are produced per year in the EU, and only 6% are recycled. This means that the construction sector uses 50% of the Earth's raw materials. Waste, 850 million tons of construction and demolition waste are generated in the EU per year, and the construction sector produces 50% of the Earth's waste. Just for those not familiar with cement, you can see here in the Portland clinker production, kilns here, we have first stage dehydration. In this zone, that's the decarbonation and calcination there, that's where the CO2 is produced. Now, how can we deal with this problem? There have been many attempts in recent years of producing, for instance, high volume fly ash concrete in order to reduce cement. Geopolymer concrete, for instance, is concrete where no Portland clinker is used anymore. Use of recycled aggregates, self-healing concrete, where the principle is to extend the surface life. Ultra high performance concrete, we can produce thinner elements, we use less concrete, and precast concrete is optimized use of materials and controlled manufacturing. By using higher strength concretes, for instance, an example here is this column. You see here the different concrete strength classes, and you see the size of the column. So of course, the higher strength class, the further we can reduce the size of the column. With ultra high performance concrete, which goes to very high compressive strength and also high tensile strength, we can use very slender structures, as you can see here, these bridge and the toll gate. Also in Belgium, we have already a couple of applications. For instance, this is a small pedestrian bridge near Brussels. This is a railway bridge in Germany. And also perhaps some of you know Musim in Marseille, where you have this filigree structure, which really is very nice. Use of recycling. So nowadays, a lot of recycling waste, concrete, and so on, is reused as recycled aggregates. And then the International Federation of Structural Concrete, and in the board of that, also a sustainability statement has recently been published, where the focus is on materials, structures, construction, conservation, dismantlement, and reuse. For instance, here you see an example. This is a bridge beam recently produced in Japan, where 150 megapascal strength is used, but there is no cement at all used in this beam. So you see that practical applications are really possible, and we can achieve sufficient strength. Also, precast concrete contributes to sustainability. Here you see a complete overview. I'm not going into the details, but this makes me to conclude that, in fact, there are several possibilities nowadays to really produce environmental concrete structures. There's still a lot to do, still a lot of research to do, but we see that also these new materials, these new techniques find applications in real projects. Thank you for your attention.
Thank you very much, Professor Luktari, for the very nice explanations of the scientific background of green building and also the various green construction materials. And also many thanks for your continuous contribution and dedication in the collaborative work between Belgium and China in the construction sector. So next speaker is Professor Meng Tao from Zhejiang University, who is also the Deputy Secretary General of Special Committee for Construction Solid Waste of the China Silicate Society. His primary research concerns advanced materials, recycling in construction, and the durability of concrete. So he will present to us the 10 years cooperation between Zhejiang and West Flanders in recycling and reutilization of demolition waste. So Professor Meng, I give you the stage.
Thank you, Dr. Lin Wang. And I also want to thank the invitation from Professor Luke Torrey. Dear friends, my name is Tom Meng from Zhejiang University. I'd like to share our experience on 10 years cooperation between Zhejiang and West Flanders in high-value utilization of construction and demolition wastes. My presentation includes 4 parts. First, I want to introduce the background of recycling in construction, and then the whole process of our cooperation between 2 provinces. After that, the recent progress in Zhejiang and the new nano enhancement technique will be analyzed briefly. As we all know, we need to conduct different kinds of engineering to make our lives better and more comfortable. However, we also bring a huge amount of different kinds of wastes. How to treat those wastes is a big problem for all over the world. Let's first look at the situation in Flanders. The whole amount of construction and demolition waste is about 14 million tons per year, and there are 285 certified recycling installations, including 4 different treatment methods. This makes Flanders as a world leader in recycling in construction. The recycling ratio achieves to 98% now. But the situation in Zhejiang is quite different. We investigate the producing of construction and demolition waste in 2016. The whole amount in Zhejiang is about 800 million tons per year. The amount of above ground structural waste is about 180 million tons per year. This is more than 10 times in Flanders. And aggregate supply and recycled products market is quite immature. This causes the recycling ratio is only 10% in 2016. Now it's about 25%, much less than in Flanders. Cooperation. As normal, our cooperation first starts from visiting and communication. Professors from KU Leuven and Ghent University in the relative research area visited Zhejiang several times from 2011. And a 5 members delegation from Zhejiang University and some recycling industries visited Belgium universities and 6 recycling factories in 2015, and also exchanged the recent research achievements. In 2016, Vice Governor of West Flanders visited 2 industries, includes 1 factory produced wallboard from the construction and demolition waste, in order to investigate the current status of recycling in Zhejiang. At that time, less than 50 industries conducted recycling construction in the whole province. In China, treatment for construction and demolition wastes starts to draw attention by the government and society. Thus, the second delegation come to Belgium and visit more universities and industries, discuss with the professor and managers, and start to think about the real cooperation on recycling between our 2 provinces. We all think a relative institute is necessary. In November 2016, Zhejiang University and KU Leuven held a conference applying for the Institute on Recycling in Construction. the governor of West Flanders and the Belgian ambassador to China attended this conference, and Hai recognized our application. Then the preparation for this institute was written on the memorandum between two provinces at the end of 2016. This is the meaning of PROR2, the institute we want to set up for recycling of construction and demolition wastes and other industrial residues in construction application. In October 2017, 4 Belgian universities and 3 Chinese universities signed a memorandum for the establishment of the Knowledge Institute for Sustainable Economy between Zhejiang and West Flanders. PROR2 is one of the 3 main parts. This slide shows the aims and ambitions of PROR2. How to develop sustainable and available technology for Zhejiang is quite important for the recycling due to the different status between 2 provinces and countries. After promotion from 2 provinces, many progress were made in Zhejiang. I'll give some examples. Several processing lines were built in recent years, including 4 recycled wallboard lines. By the way, wallboard is also encouraged by the Chinese government. This new factory located in Jinhua City has a complete set of crushing, construction, and demolition wastes, producing recycled aggregate, recycled concrete and blocks, and cement stabilized recycled materials. This line is dealing with the decoration wastes in Jiaxing City. We can find there are many plastic bags, ceramic tiles, wood, and other impurities inside. This deeply increased the difficulty of treatment. So how to find a suitable recycling method in Zhejiang is a new research item. Thus, the Department of Science and Technology of 2 provinces decided to support relative research in this area. We succeed to apply for one. Our project is concentrated on mixed recycled aggregate to study key technology of resource recycling and conduct demonstrate applications. These 5 photos show the research process of this project in these 2 years. The efficient utilization of building solid waste should be studied according to different particle size. This is the roadmap of our project. However, mixed recycled aggregate is normally very weak and high absent. So we need to find an effective method to strengthen this kind of aggregates. In Zhejiang, we use nano technique. We call it nano enhancement. In this part, I'll explain the effect of nanomaterials on properties and microstructures of cement-based materials, and introduce our experimental results on nano enhancement for the recycled aggregate and recycled concrete. In recent years, nano cement and nano concrete have drawn close attention in the world. We can find the rapid growth of this research. From this side, we can know different kinds and different properties of nanomaterials could cause different effects on cement and concrete. However, the mechanism still focus on the filling effect, high activity, and the seeding effect of nanomaterials. We need to conduct further research. We found compressive strength of cement paste is linearly related to the orientation index of calcium hydrate. Thus, we propose a new mechanism of nanomaterials, the bunching effect. Some detailed results will be published in the near future. And also, we conduct quantitative XRD experiment to find the change of composition and the content of minerals in clinker and hydration products. We can find this is quite different for different nanomaterials. Then we proposed the hydration model of nano-modified cement. Based on those research, we start to use nanomaterials to strengthen the recycled aggregate. 3 different nanoslurries were used in this experiment, and the total solid content of nanomaterials is 2%. We can find the crush index and the water absorption decreased. The reason for these results was that the pores could be blocked by nanomaterials and hydration products from nanomaterials and cement. Thus, the total pore area decreased sharply and the strength increased. This slide shows the mechanism of nano enhancement. This is the recycled aggregate. This is the recycled aggregated modified by nanomaterials. And this is the recycled concrete. Some structure properties also were conducted. We can find the force and moment of beam could be increased after nano enhancement. And the low slip curves showed obvious difference from the poor lot test. This confirms the effect of nano enhancement. In order to study the nano enhancement in real engineering, 3 beams were casted. From left, we can find the red one is the new beams. From left to right are concrete beam with 100 natural aggregate, concrete beam with 100 recycled aggregate, and a concrete beam with 100 nano-modified recycled aggregate. We called it NC, ORC, and MRC. We can find the microstructure of interfacial transition zone. The tensile strength, compressive strength, and long-term load strength could be obviously improved by nano enhancement. It is truly a kind of efficient method for improving the properties of recycled concrete. Now we use nano enhancement in many areas. For example, the high strength recycled blocks, recycled concrete, and high performance recycled, marine recycled concrete, and so on. That's all for my presentation. Thank you for your attention.
Okay, thanks, Professor Meng. It's a pity that we couldn't see the interesting cooperations, the details. But it's always great to see that there is collaboration between China and Belgium, and we work together for more sustainable built environment. So we've heard the views on green building from academia. Now we'll look at some industrial examples. The next speaker is Mr. Vincent Mestach. So Vincent has a background in engineering from KU Leuven. He holds an executive MBA from the Kellogg School of Management at Northwestern University and is now the CEO of Ecolodge. He will present a great green building product from his company called VaultCube. So please, Vincent, when you're ready.
Good morning to people in Europe and good afternoon to people in China. Thank you very much, Lynn, for this kind introduction and for the invitation. Is everybody hearing me well? And do you see the slide?
Yes, we can see you on the slide well.
Perfect, thank you. My first slide is the following, where you see those 2 pictures. This is a great summary of what I am going to explain now. On the left side, you see wood and straw direct from the field. And on the right picture, you see one of the final products my company makes. So basically, the designer started to make passive buildings made of wood and straw in 2009. And we founded a company in 2017, which is called Ecolodge. And the purpose of Ecolodge is to make green building more affordable. And a few months later, that's when we built our first wall cube. This is the name of the product, wall cube, and this is the building you have on the right picture. How do we make this? Basically, we build a frame of wood, and between the elements, we put straws. It gives us high performance building envelopes with a great thermal insulation, a very good acoustic insulation, and the last and certainly not the least, the users, the people living in those buildings have a very high comfort level. And in fact, it's like we are doing high-tech engineering with low-tech products. So we should call it low-tech engineering. And we think this is a great way to give an answer to today's environmental challenges. Sometimes we need to go to ancestral products to create great new products. If I make a drawing of this wall, you see that you have two options. Either the straw carry the load of the building. In this case, you don't need a frame. But if the straw does not carry the load of the building, we need a wood frame. And on most of the time, on both sides, the inside and outside, you have panels, different types of panels. It can be wood panels, it can be other type of panels that give some more structure and also some resistance to vapor as well. Those walls can be directly shipped to the job site. This is one example. And we build the building this way. It's a great way also to do the renovation of high-rise buildings by giving them green envelopes. What my company makes is that within the plant, we build modules, which is what we call 3D modules, from three-dimensional modules. In this case, the waterproofing is already installed on the roof, the cladding is already installed, the windows are already installed, and sometimes we also install the kitchen and bathroom and other ingredients. Those boxes are shipped on the job site by truck. There is trains to move them so that we can assemble them on the job site. It's very, very fast. And the big advantage is that the straw and the wood never gets in contact with water. We have different size of wall cubes going from 25 square meter to 110 square meter. We can assemble them together so that you can make bigger spaces. And it's pretty fast to build and to install because we do not depend on the weather. Everything is manufactured within the facility. Depending on the models, it takes between 15 and 60 days to manufacture the 3D modules. On the job site itself, we need 1 day to make the foundations, and then we need another day to assemble all those modules together. So basically in the morning you have nothing, and at the end of the day you have a buildings there on the job site. And if it's not installed in advance, then other contractors are welcome to install the kitchen, the bathroom, and also some partition walls within the building. This is a general view of our main models. You see, we can put them together to make bigger spaces, and the smallest is this one, we call it 25. This is another one. This is a doctor's office next to his house, which is the model 30 because it is 30 square meter. This is a vacation place and the surface is 44 square meter. This is a training center, a bit bigger. This is a single family home which combines two sides of wall cube, 82 and 25. This is a vacation village that counts 22 units and are all made of wall cube 44. And we work on eco districts, which is becoming very popular, where people want to enjoy a smaller place to live, very green place, and also share maybe crops they can grow together, and they share cars and so on. So at the end, what we offer are net zero energy buildings made of green materials. Wood and straw are the main materials. And not only they are green, but they come from very close by. So 95% of the material are coming from a distance lower than 200 kilometers. And wood and straw don't need a lot of energy to be ready to be used as building materials. And moreover, they can be used as CO2 reservoirs. Another very interesting feature of those modules is that 95% of it is reusable for new buildings. We have done that for centuries in Europe to reuse woods, mainly for roofing, but also sometimes as structural elements for some smaller buildings. And if you don't want to use those materials, if you let them go with no maintenance, then at the end, it's a compost. They just simply disappear in the nature. Another very important advantage is that you can move those modules. If you want to move location and keep your house with you, you can still do that. You can move the boxes. And because the space are auto-stable, you can put the partition inside the module wherever you want, as long as you accommodate the existing windows. So it means that over time, the function of the building can greatly change over time. What my company Ecology is looking for is real estate developers to build more wall cubes. We're looking for investors to increase the capacity to manufacture more wall cubes. And we will be happy to find partners ready to manufacture those modules around the world. So I will finish this presentation by thanking you for attending the presentation, and I hope together we can make this world better, a better place for us and for the next generations. Thank you.
Thank you, Vincent. So if somebody wants to build a new house or want to spread the idea of using ancient materials, please contact Vincent. So because Vincent used only about 10 minutes for the presentation, we'll have one question, because I see in the chat, Tina Huang asked the question. I wonder if there is a quality concern from the turbulence during the transportation. And for your information, Vincent, this might be a potential customer because Tina is planning to build a new house.
Well, good to know. So those boxes, those modules know the higher stress during transportation. Just think about wind. If the truck is on the high-speed highway, it drives 100 kilometers per hour, and then you get the wind in the opposite direction. So it's like a storm that can be 200 kilometers per hour. So basically, if the transportation happens with no problem, which has been the case so far, you can be pretty sure the building will last for a very long time. But to answer more directly the question, we have designed the modules to resist the transportation, and also all the manutention we do with the crane.
Okay, thank you, Vincent. And Tina, if you want to know more, you can go to the website. You can just Google VaultCube. You'll find more information. So thanks again, Vincent. And I know you're at the airport. I wish you a good flight.
Thank you. Have a good conference.
Thanks. So the next speaker will welcome Professor Song Ye-hao. So Professor Song is the Director of Institute Architecture and Technology at Tsinghua University, the co-founder of SUP Atelier, as well as the Secretary General of the Green Buildings Theoretical and Practical Group of the Chinese Green Building Committee. So he will present to us the implementation of materials of low embodied energy in green architecture. Professor Song, please.
Okay, thank you, Dr. Wang. Then can you see my screen?
Yes.
Yeah, perfect. I got my slides on and moving a little bit. So it's a test, just in case. Could you see that? Yeah?
Yes, perfect.
Okay, I just go on. My topic is about material, because talking about green architecture and a sustainable future, material must be one of the most important part for architects, engineers to focus on. So we have kind of basic ideas for and terms, concept for embodied energy, which means from raw material to components and to the construction site, and then part of the building, how much energy consumed. And we have kind of idea and concept. And talking about something happened in China, bamboo is one of the best sustainable material for this. We do a lot more experimental architectural design construction works for that. So we you can see the chrono. Yeah, you can see the timeline. Okay. And also in ancient China, sometimes we pay much attention to the harmony of mankind and nature, which means not all the buildings must be necessarily enveloped. So we have kind of open space, open view, and together with nature. So in which field bamboo could play an important role for that. So that's the distribution of bamboo resources and all over the world, and then some kind of microscope, research on bamboo as a material, and also a lot more ways for bondage, for bond and for joints of bamboo. The first case for us is we call it village lounge, because it's for the villagers to do something together. It's kind of retrofitting project, but on a totally abandoned family house. Yeah, you can say something like that. But with bamboo, in a very short period of time, we provided with villagers something they are really fond of. And thanks to their devotion, the villagers are not only the owners, but also the builders of this small project. So first time we taught bamboo as construction material. And we understand some principles for bamboo as construction materials, and also advantage and both advantages and disadvantages. After that, we have another small pavilion just in Beijing, the Beijing Forestry University, not far away from my university. It's kind of information pavilion, and also a lot more events could be done there, yeah, for opening ceremony and also for daily life of old people and their grandsons and daughters, and also for students and professors in that university. We have a lot more architectural thoughts, yeah, but that's not the particular point for this presentation. We pay much attention to the environmental factors of the surroundings, like the acoustic, and then about the accessibility of the building, and also the context. We call it urban context, the whole thing around it. And we do a lot more research, architectural way, and also after that it's something like that. We do a lot more research on the joints. Mention the joints. Talking about joints, we're trying to connect each and every bamboo, yeah, with a traditional way and with modern way, with help of nails, and do the analysis for the displacement of the elements, and try to combine something modern together with something traditional, which means the craftsmanship and also the events were going on there. Kids definitely are fond of this pavilion. They can exploit the extreme of the building. They love that place for sure. And students also. Elderly people together with their grandsons and daughters, and all in a tranquil atmosphere. After that, one of the latest bamboo project of our office is the tea market in Fujian. Fujian is famous of one thing, at least, the tea market. A lot more teas from that place, and also in architectural context, also very much famous for the rammed earth buildings, traditional rammed earth building. And also, maybe it's something special, but the structure of bridge is quite particular with timber in the traditional way. So that's the surrounding context. And we're trying to find everything in the limit, which means 20 kilometers. We try to do something. And materials, less than 20 kilometers. We find the rammed earth, just the surrounding, not far away from the construction site, and also the traditional Chinese timber bridge, very near to the site. And talking about rammed earth is something also with a very low embodied energy. Yeah, it also with long history. We do the reuse research on that, and abandoned houses with timber thing. We also make full use of them again in the building, and also abandoned everything, the broken stone plates, kind of waste, but we try to reuse them again. And we do a kind of rough calculation for the life cycle material, carbon emission thing, and try to find loops for every materials. Another thing, last but not least, maybe of great importance, is the craftsmanship. We ask local people to do something for themselves, which follows all the principles of our design. So they are doing something for themselves. Could be tea market under a vaulted bamboo roof, which learned much from traditional Chinese timber bridge. And also again, the joints, the coverage for that, traditional craftsmanship for the rammed earth, starting from reuse of the stone. and then local people for themselves. 2 workers could make a wall in 2 days. That's quite fast. They're doing that for themselves with joy. And that's the timber bridge around, several kilometers away from the construction site. We do comparison with the rainbow timber bridge. And also Leonardo da Vinci did something for that system. That's a traditional Chinese system. Yes, the old timber bridge with hundreds of years of history. Rainbow. Yeah, that's, yeah, Chinese must understand the significance of that traditional Chinese painting, yeah, within the capital city of Song Dynasty with rainbow bridge with timber. So we learned something from that and try to do the comparison with the traditional timber bridge with rainbow bridge, and then do a lot more analysis and design work for that. And finally, we have our own particular, the bamboo, woven bamboo bridge. It's not for bridge, just for the coverage of a huge span. So it's kind of roof. Yes, do the detailing. And again, joints, detailing design. And under construction, do the experiment to test if it works or not. And then after a very short period of time, 30 days or something like that, that team market was done, finished, accomplished. So that's a rendering, yeah, for our research, and gradually done. That's the reality after accomplishment. And also users for less than 20 kilometers, we are doing something for local people, not for tourists, not only, but also for local people. Why should not they enjoy kind of thing for that? So we do a lot more research, investigation, and for local people's habits, hobbies, and also events, festivals, whatever, we try to provide some kind of multifunctional space for them. So it could be something. Yeah, that's the vision. Yeah, we could be a cinema for movie night, could be a grocery for daily life, and could be a tea house for everything. Yeah, that's quite special. They have this kind of feast. In a particular day, each and every family will provide dishes and just move to the street, and they will invite all the guests or villagers to enjoy their dishes. So after the accomplishment of the tea market, they have a regular place. It could be against the sunshine, against the rain water or whatever might be disturbing. All that's under construction during construction course, and local people, the villagers are curious about the material, bamboo. Yes. Terrazzo, yeah, on the ground. Terrazzo is part of the reuse of the broken stone plates. Yeah, we knocked it again to some small pieces, and then make it a part of terrazzo. So it's kind of dark red color, which is color of the stone. And also another part for the broken stone plate is for the pavement. Rammed earth wall. We inserted several timber inside of the the wall, to make it possible for the villagers to nail something on that, because ramped earth cannot bear the load, but the timber can. So that's a side of the building. Or reuse of the abandoned timber for landscaping, for stools, for chairs. Yeah, you can see the terrazzo. Oh, that's and we do have a lot more architectural ideas, concepts, except for the structure system. We do a lot more detailed research to try to make it more elegant, more, even I would use the word beautiful. You know, it's not common for an architect to say something like something beautiful, but we are trying to do that. Very elaborated thought. Yeah, that's in the night. Even for lighting, we invited the top consultants in China to do something for the local people. And Imba Pavilion is the last bamboo project for our office. It's kind of small pavilion for expo in Yangzhou. We will make it. It looks like a fish. Fish means something good for Chinese people, so we try to make it like, could be for a wedding or for a kind of ceremony. Could be also multifunctional thing. Yes, we also do a lot more comparison for structural system, and also for calculation. After that, we try to finally made up of mind to find one optimized solution for that. Just a displacement or a lot more, you know, terms for that, but that's not the most valuable part of design. It's kind of comparison, you know, always painful to make up mind for design. That's also kind of joints and design part, and you can say the size, you can say dimension. That's adult, you know, maybe 1.7 meters, you can say.
Professor Song, very nice presentation, but
yes.
You have half a minute left.
Yeah. I just go slides. Okay, thank you.
Thanks.
Yeah, because it's something very easy to understand. So, okay, another one is about brakes. Just slides. Okay, it's also for villagers, for local people, even for relatively poor people. Still could be something sustainable. Depends on the intention of design and the sake of beauty. Okay, that's all. Thank you. Thank you very much.
Thank you, Professor Song. It's a very, very nice presentation. It's really great to see the beautiful and very artistic bamboo structures. I wish the audience and myself will have the opportunity to see more in the future. So thank you very much.
Yeah, thank you. Thank you. All is mine.
So now let's move from China to Belgium and hear about the green building concepts of a new project now under construction in Brussels. It's called ZIN. Please welcome architect Mr. Loïc Ayes from Jaspers Ayes Architects. So Loïc.
Yes, good afternoon, everyone.
Hi, Loïc. So actually, yes, Basics is also part of the ZIN project. So I can't wait to see your presentation. So please, when you're ready.
Thank you. I will share my screen. Can you see my screen?
Yes, we see the building.
Yeah, this is actually the perspective of the building on which we are involved today. It's under construction. This is a rendering of the future project. And we are actually in the high-rise district next to the city center of Brussels. And it has been one of the first high-rise towers in the 60s, in 1960. So this was the former World Trade Center in the city center of Brussels. And this is a photo of when it was constructed 50 years ago. And it was actually part of a bigger master plan and an American vision for Brussels to start constructing towers in a high-rise district. And today it's been evolved in an area with a lot of towers next to the one of the most frequented train stations in Belgium. It's been an area in full transition. There is something going wrong with the text, but I will explain. And the area was a long time an area with monofunctional office blocks. It's been an area with a lot of governmental administrations, and it's been regarded as an area with not a lot of life in the evening when people in the offices are gone. And so the interest of the city and of the local community today is to bring life with new projects, with a mixity of functions in those new buildings. And so what was really nice was that our client invited us a whole team of local experts to think about what the future of this new development might be. And they actually invited us in the existing towers. So the towers from the 60s to think and to develop new ideas for this project. And so we came up with this idea to bring more of a mixed project, because before the two towers were only housing offices, but in the future, when our project will be finished, we will have, of course, the offices, but we will also house 100 apartments, 111, and 240 hotel rooms. And this way, we think we might create life in this area, in this quarter, also in the evening, at night, early in the morning. And so this is actually an axonometry. On the left, you see what was there, and on the right, you see our new project. And so instead of just demolishing the existing towers, we really studied and looked at all the materials we had on site. And we wanted to bring a new project, but without demolishing what was there. So we wanted to be very conscious with the bank of materials, so to say, and try to do something with them in the future project. So we came up with this idea to not really demolish the foundations, not to keep the existing structure underground in the parkings, and to keep the existing concrete cores, and to build the new project around them. So to avoid a lot of traffic of demolished concretes to leave the city and to be processed. And so we came up with this idea to connect the two towers, the two cores of the towers, with a new volume, a double height volume, which will house in the future offices, but a volume with a height of 5 meters 20. So in the future it can house also other functions than only offices, because we would like the building to be flexible and to be a structure which can be used and which can evolve in time, and which can be inhabited by different various occupants in the coming decades. And so actually we made an inventory of all the materials on site to try to give them a new life in the new project without while not wasting things which can, for example, be used in the future project or in another project. So like the aluminium, the concrete, you see here a photo of the floor tiles. They all were collected, and they are, for example, these floor tiles from the existing towers, they are now waiting in a local storage area to be reused in the future project. And by doing this inventory, by doing the investigations on what is the content of the materials, we were able to only have 5% of waste of the existing towers and the existing project. So this waste is like, for example, polluted materials we weren't able to reuse. And we are also consciously selecting the new materials for the new project, because we really want to avoid there to be any waste in the future of them. So we prefer to choose, for example, materials which can be easily demounted, which are dry, which can be adapted or taken out and applied somewhere else. And so, for example, this is a survey, or yeah, it shows the technical sheets of the materials. So the owners in the future will exactly know what is in the building, what is the value of these materials, and how can we use them. Yeah, this is actually a plan to understand better the project. You have the two existing concrete cores and then the new volume in between. And this is the plan of the apartments and the hotel rooms, and a view of the model of the project. This is a perspective of the central area, the double height area. And which can house auditoriums, landscape offices, closed offices, maybe laboratoria, different kind of spaces in the future. And what was also important for us was to invite greenery inside of the office spaces here, for example. So there is this raised floor of 60 centimeters, which allows us to have living plants in the area. And yeah, our client today, he has a very specific program. He has a client for the building today, but we wanted the building to be flexible in the future. And so here you see some schemes with colors, the red color, for example, indicating the office function. But we wanted to design the building so that there is a certain flexibility. When, for example, there is less need for office space, we can easily adapt and invite inhabitants and change the function from offices to apartments. And so this section, it shows, for example, how we only use dry materials which are specific to the functions. So to say, the raised floor used for the offices can be easily taken out, and we can apply floors or materials to house these other functions. So the curtain wall is actually designed with openable windows everywhere, but with a flexible modulation to easily adapt for the occupants. And we avoided to pour or to use materials which are not dry, which are more difficult to take away and adapt when the function of the occupants change. And of course, the project is neutral in energy. So we have geothermal pumps, we have solar panels, we have there is the technical installations who exchange warmth from the offices to the apartments in the evening, or the other way around, the warmth of the apartments in the morning to heat the offices. But for us, it is evident to use all these kind of new technologies to make the building neutral in energy. But we think it is more important to design a building as to be flexible to house these different functions in the future, and to really know the materials who are used. This is a diagram showing that given the different users, there is a lot of functions which can connect the different users. For example, there is like this communal winter garden in front on the ground floor, sport facilities which can be used by the office users, but also by the people living in the apartments, or the visitors of the hotel. And the spaces on the ground floor, they are designed to interconnect, so that all these users can connect, can meet, can easily interchange with each other, because we think it is really important to have a building plan which is lively, and where a lot of people can come together and meet. And yeah, at the end of this presentation, I have some more images of the volume. What you actually see, the brown volumes are the two existing towers, how they are today, and then a lighter double height volume in between. So the future project still respects the composition of the past, and you still feel from where this project was coming. Yeah, you see that, for example, on one floor there is the office spaces with the terraces, and one floor below you have the apartment buildings and the people living there. And this is about it.
Okay, thank you very much, Loic. I look forward to seeing the buildings when the renovation is done. And hopefully the audience in Belgium can also go pay a visit. So now it's time for the last presentation by Mr. Liu Lei. Mr. Liu is a nationally registered architect, both in China and France. He is the president of China branch of Sino-French Architecture Society and the co-founder of PA Design Architects in Beijing. He will present the design strategy for special shaped buildings based on digital models, and taking the example of the CCTV animation pavilion. So please, Mr. Liu.
Hello, everyone. Good afternoon. Okay, I will share my screen. And can you see that? See the slide?
Yes.
Okay. So, okay, today I'd like to introduce a little pavilion in the 2019 Beijing Expo. It's a, in fact, it's not a green building, it's a red building. Yeah. In 2019, China-Beijing International Horticulture Exposition is held, and it is the highest level international horticulture expo approved by the AIPH, sponsored by Chinese government and undertaken by Beijing. And at the opening ceremony of the Beijing Expo, Mr. President Xi Jinping stressed the development model of killing the ghost to extract the golden eggs and draining the pond to fish has come to an end. Green development that follows nature and protect the ecology holds the promise of the future. And the theme of the Beijing International Horticulture Expo is Green Life, Beautiful Home. Now is the bird view of the whole park on construction. And this is one of the biggest pavilion, Set Wanke Pavilion is in fact a botanic greenhouse. And from the roof of the Wanke Pavilion, you can see this is the Chinese, the pavilion of China. And what I made is this little red building called CCTV Animation Pavilion. And it is sponsored by the CCTV Animation. It's an enterprise who made animations for the Chinese children. And this is the building. It just in a very, very kind, very friendly environment. And the first phase is design phase. It's located in the education and future exhibition area in the west of the expo. And it covered 1,000 square meters surface, but the building is little, it's about 368 square meters. It's in, the inspiration is from the legend of Naja, which is a canton of old Chinese story. So we take this ride, we can see that Silk Tower, it's in fact a weapon of this canton. So 2 pieces of red tile enclose the exhibition space and the roof garden. The shape is pulled from the rhino model, and the shape is bold and restrained. So the plan was obtained by intercepting the plan section from the proposed rhino model. The wall curve is irregular spline curve formed by free stretching, so which is not conducive to lofting or to construction. So we use the continuous curve with transition smoothness and formed by splicing the circular arc segment so that any curve on the plan has corresponding center, radius, starting point, and point, which is conducive to the operating of plan laying out and the accuracy of construction. And then we remade the rhino model according to the optimized curve. And then we also made a physical model to verify the observer's true perception of the future building. And then according to the digital model, and we redesign it in the plan, the steel columns, beams, and the composite floor rearranged. And then we put it in the rhino model according to the structure layout and a detailed beam columns section. The conditions are reflected in the digital model. And then we use Tekla model is also established according to the digital model. The manufacturer processing drawing is produced according to the batch and delivered to the factory. So Tekla is a software universal. And then we also delivered this writer model to the curtain wall design architect who is majored in designing the curtain wall with aluminum. And on the same time, we also do the design the outer curtain wall, which is a wind bell blade. And after the information of the steel structure curtain wall and all the equipment is added to the digital model, the architect needs to synthesize all the information and draw the construction drawings. And we also join some detailed drawings and find some problems which the model, the digital model cannot find. And the next is the construction phase. So the laying line work is a little bit embarrassed because in the orthodox system it's very easy, but in the curve system, so we need more accuracy and more strategy. We also use the UAV to survey and to inspect the accuracy of the position of the foundation pit, and we find many problems and rectify it. This is, we required the construction groups to rectify the foundations. And at the same time, the processing of steel structure lasted for more than a month, and the processing of 3D curved steel beam was very complicated. It needed a lot of artificial work, and it took workers more than another month to complete the installation of the steel framework on the site, and the temperature is very low, it's 10 degrees below zero. And at the same time, we also studied the wind bell blade, and we find the blade can move back and forth, and at the same time, left and right. The skin is not smooth, so we use a little, how to say, a locator to limit the movement up and forth, back and forth. No, to limit the left-right sway. Only let it can move back and forth. So after 1 month of installation, the skeleton of the building has appeared as beautiful, perhaps more than after it finished. And after the completion of the inner curtain wall, the building has become a sculpture, a red sculpture. And finally, we installed the wind bell blade on it. Then the building is dynamic. So we use a cable independent from the inner curtain wall, handled by the roof and the basement, and we put the round blade on it. Yes, because this is a curved building. If we use rectangular blade, it can interfere each other. So after completion, this is the bird view of the whole building. We can see this is the entrance of the ramp. From the ramp and the staircase, you can get up to the roof garden. From the roof garden, there's a little entrance downstairs to the main hall. In fact, it's a cinema hall. And at the same time, we also designed a spiral staircase in the purpose of evacuation. So, and there's the roof garden. Yes. And this is the main elevation of this building. And we can see animation here. Yeah, in the wind, the blade move and have an expression of like a silk. So when the wind is light, it expressed a feeling of a very delightful. Okay, next. And this is also the elevation, the security guard. Yes. This is the entrance of the ramp. Yes. This is the spiral staircase. When the wind is strong, the feeling of this curtain wall is a little angry, I think. So this building is not stable. It's also a dynamic, and it can express different feelings of the nature of the wind. So it is different from the architecture traditional. So the wind is strong. It's really like the self-toe of Nadar, the animation, who use it as a weapon. And combined with the green grass. Yeah, this is a detail of this. You can see the cable vertical and some cable horizontal to fix it, and the ground blade with a little point fixed on the cable. And this is the ramp. In the middle of the ramp, there's a little garden and in a style of animation. And this is the staircase up to the roof garden, like a gauge or Great Canyon. This is roof garden with, this is the animation of panda and the mall of Czechoslovakia. This is the entrance, the roof of the entrance downstairs to the cinema hall. And from the roof garden, you can see the giraffe on the top of the Wanker Pavilion and the Yunning Tower. And this is the interior of this building. In fact, it's a cinema hall. We can see the beams focus on one point. And this is the opening ceremony. A very famous host was invited to the site.
Mr. Liu, very nice project. If you could sum up in 1 minute. Thank you.
1 minute, okay. We also finally win the God of War from the expo. So finally, I will see some thinking of this little building. The first, I think, architecture is not through the music, perhaps. It may be fluid. The second, architecture is not only the expression of humans' own will, but also the interaction of nature. It is the expression of the will of the wind and water. Finally, green building perhaps is not only filled with or covered with green plants, or not only passive energy saving buildings, not only low carbon or zero energy consumption building. It should also be environmentally friendly building like this building. It's the true feelings of nature. That's all of my speech. Thanks for your attention. Thank you.
Thank you very much, Mr. Liu, for the next presentation. It's indeed a very interesting project, especially with the dynamic effects. So due to the time limit, we're reaching the end of the green building session. I want to thank all the distinguished speakers and the guests again. I hope you enjoyed the nice presentations and learned some useful green building concepts. Now we'll move to the closing ceremony of the symposium. So thank you very much, and I'll see you next time.